Ready to dive into the quantum realm. We're celebrating 100 years of quantum mechanics.
The International Year of Quantum Science and Technology.
A perfect time to explore how it's changed our understanding of the universe.
You know, before quantum mechanics, we didn't really get the universe at the atomic level.
So, no lasers,
No.
smartphones,
Nope.
MRIs.
None of it? Wild.
Yeah, it really makes you think how different things would be.
Absolutely.
So get ready for some line-bending concepts.
Like superposition,
Entanglement,
spooky action at a distance.
and Heisenberg's uncertainty principle.
It's going to be a wild ride.
So take us back to the beginning. How did this quantum revolution start?
Well, picture this 1925, the Solvay conference in Brussels.
Okay.
A room full of physics giants. Like Einstein, Heisenberg, Schrödinger.
Wow, what a lineup.
All struggling with a problem that classical physics just couldn't crack.
Okay, so what was the problem that had these brilliant minds stumped?
Well, classical physics worked great for big stuff like planets, projectiles, pendulums. But when it came to the tiny world of atoms, it just fell apart.
So like what specifically?
Well, for instance, why didn't electrons orbiting an atom just spiral into the nucleus?
Causing the atom to collapse.
Yeah, classical physics couldn't explain that.
So there was this fundamental gap in our understanding, and that's where quantum mechanics steps in.
Exactly. This is where these groundbreaking ideas like Heisenberg's matrix mechanics and Schrödinger's wave equation came in.
Big changes?
Huge. There were radical shifts from classical physics, proposing that particles like electrons acted more like waves than tiny balls.
So not everyone was on board with this new way of thinking, right? Didn't Einstein resist these ideas initially?
Oh, he did? His famous quote, "God does not play dice," really sums up his discomfort with the uncertainty of quantum mechanics.
That's a great quote.
But the evidence kept piling up. Quantum mechanics explained things like atom stability, how light is emitted and absorbed, even the periodic table. By 1927, the scientific world was changed forever.
So from fumbling in the dark about the atom, we suddenly had this new framework that illuminated the building blocks of the universe.
Exactly.
But this wasn't just some abstract theory, right? Quantum mechanics has had this massive impact on our everyday lives, hasn't it?
Oh, absolutely. The impact goes way beyond theoretical physics. It's the foundation of modern technology.
Give us some examples.
Lasers, semiconductors, transistors, MRIs, they wouldn't exist without quantum mechanics.
Wow, it's everywhere.
It's like a hidden force shaping the modern world.
And not just gadgets. Quantum mechanics also changed how we understand how atoms bond.
You got it. It's the basis of modern chemistry.
It gave us the tools to understand how electrons interact, which led to all sorts of new materials and medicines.
And it even helps us understand the cosmos. Things like nuclear fusion that power stars and the evolution of galaxies.
That's incredible. So we've gone from not knowing how atoms work to understanding the universe on a grand scale.
All thanks to quantum mechanics.
So let's talk about some of these mind-boggling concepts that quantum mechanics introduced, like superposition, the idea that particles can exist in multiple states at once.
Right. Imagine a spinning coin. It's both heads and tails until it lands and you see the result. In the quantum world, particles can be in this blurry mix of states until we measure them.
So they're forced to choose one state when we look.
That's the strange but true reality of quantum mechanics.
Okay, so what about Schrödinger's cat? That's like the classic example of superposition, right?
Yep. Imagine a cat in a box with a device that has a 50-50 chance of releasing poison.
Oh no, poor cat.
Until we open the box, the cat is considered both alive and dead.
Okay, that one always makes my head spin.
It's a tough one, but it highlights how strange the quantum world can be.
And then there's entanglement, spooky action at a distance.
That's right. Entanglement means two particles are linked, even across huge distances.
So if you change one, the other changes instantly.
Exactly. No matter how far apart they are, Einstein called it spooky action at a distance for a reason.
I can see why. If particles can be in multiple states at once and affect each other instantly, doesn't that mess with our ideas of cause and effect?
It definitely challenges our intuitive understanding of how things work.
And we can't forget Heisenberg's uncertainty principle. That tells us there's a limit to what we can know about a particle's properties, like position and momentum.
Right. The more we know about one, the less we can know about the other. It's a fundamental limit of the universe itself.
It's no wonder quantum mechanics is mind-boggling. We've got particles in multiple states, linked across vast distances, and this inherent uncertainty about their properties.
It's a testament to human curiosity that we've come this far in understanding it.
Speaking of which, it's the International Year of Quantum. How's the world celebrating this centennial?
Well, there was this amazing opening ceremony in Paris on February 4th, and there are events all over the globe, conferences, lectures, even interactive exhibits.
I read about Quantum Fest at the American Physical Society Global Physics Summit in Anaheim. That sounds amazing.
Oh, it is. And it's not just about the past. We're looking ahead to the future and inspiring the next generation of quantum scientists.
So this celebration isn't just about looking back, it's about looking forward to what's next.
Exactly. As physicist Smitha Vishweshwara said, it's about awareness, bringing communities together, and inspiring the new scientists.
I love that. But before we get to the future, we have to admit that even after a century, some big quantum mysteries still remain.
Oh, absolutely. There's still so much we don't understand.
So what are some of the biggest questions that keep quantum physicists up at night?
Well, one of the most basic questions is, why do particles behave so strangely at the quantum level? And what's behind entanglement, this spooky action at a distance? And how do larger objects like us transition from the quantum world with its superposition and uncertainty to the classical world we experience every day?
That's decoherence, right?
Yeah, and we still don't fully understand it.
So even though we've harnessed the power of quantum mechanics to create amazing technology, we're still trying to unravel its fundamental mysteries.
It's like we've learned to use the tools without fully understanding how they work.
And speaking of amazing tools, what about that recent LIGO breakthrough? They reduced the vibrations of their 40-kilogram mirrors to near the quantum limit, essentially creating a 10-kilogram quantum object.
Isn't that incredible? It could completely change our understanding of why large objects don't usually act in a quantum way. It might even help us connect quantum mechanics with Einstein's relativity, which would be huge.
Two of the biggest ideas in physics. So it seems like we're on the verge of some major breakthroughs in understanding the quantum world.
We are. And who knows what incredible applications we'll uncover along the way.
I can't wait to find out. But I think that's a good place to stop for now.
Sounds good. Back again for more quantum adventures.
I'm still trying to wrap my head around all these mind-bending concepts.
It really is remarkable how quantum mechanics has changed our understanding of the universe.
From tiny particles to giant cosmic structures.
Exactly.
It still feels like something only physicists with PhDs can understand.
Oh, I don't think so. At its core, quantum mechanics is just how nature works at the most fundamental level.
It's not about magic.
No magic.
Just observing and understanding those strange but beautiful rules that govern the universe.
And even if some of those rules seem counterintuitive, they've been proven time and time again.
It's not like physicists just made this stuff up.
Definitely not. Over a century of research went into this, from Heisenberg and Schrödinger to the experiments happening today.
And those experiments are still pushing the boundaries of our knowledge, challenging those assumptions about reality.
Like that LIGO breakthrough we talked about.
Reducing the vibrations of those massive mirrors to near the quantum limit.
It's amazing what humans can achieve.
It makes you wonder if we can bridge the gap between the quantum world and our everyday experiences.
It definitely raises questions like, why do large objects lose their quantum properties?
And can we use those properties in new ways?
Exactly. Which brings us back to the future of quantum mechanics and quantum computers.
We barely scratched the surface last time.
Quantum computing is one of the most promising areas of quantum technology, with the potential to change so many industries.
So let's go deeper. How could quantum computers actually transform different sectors?
Well, in medicine, imagine personalized therapies designed for your specific genetic makeup.
Wow, so not a one-size-fits-all approach.
Exactly. Treatments tailored to your needs.
That sounds like science fiction.
It could become reality through quantum simulation, simulating complex molecular interactions at an atomic level.
So breakthroughs in drug discovery.
Gene editing, personalized medicine.
What about beyond healthcare? What other fields could benefit?
Material science, for sure. Quantum computers could help us design completely new materials with amazing properties.
Like lighter and stronger materials for transportation and energy.
Exactly. The possibilities are endless.
But are there any downsides to this technology? Things we should be cautious about?
That's a great question. One concern is the impact on cryptography.
Right, because a lot of our encryption relies on math problems that quantum computers could easily solve.
Yeah, it could be a real threat to cybersecurity and data privacy. Imagine all our sensitive information vulnerable to hacking.
That's a scary thought. So as quantum computers get more powerful, we need better security measures to stay ahead of the game.
Exactly. It's a race against time. And this brings up a crucial part of the quantum revolution. It's not just about the technology, but the ethics behind it and developing it responsibly.
We need to think about the societal impact and make sure it aligns with our values.
We need open conversations about the benefits and the risks. And not just scientists and engineers, but policymakers, ethicists, and the public, too.
It's a reminder that the quantum revolution isn't just a scientific endeavor, but a societal one.
We all have a role to play in shaping its future.
You know, one thing that stands out to me about quantum mechanics is the international cooperation.
Oh, absolutely. Scientists from all over the world are working together to unlock the secrets of the quantum world.
It's inspiring to see researchers from so many different backgrounds coming together.
That collaboration is key to solving those big quantum challenges, like understanding entanglement and harnessing the power of quantum computing.
It takes a global effort to make these breakthroughs.
And as we celebrate 100 years of quantum mechanics, it's great to see that collaborative spirit thriving.
You know, one question I keep coming back to is how do macroscopic objects like us lose those quantum properties?
That's the mystery of decoherence. Why don't we see cats in superposition states?
It's so strange that the quantum weirdness disappears as things get bigger.
Some theories say that interacting with the environment disrupts the delicate quantum states.
But it's still an open question.
It's a fascinating area of research with huge implications for things like building quantum computers and even understanding reality itself.
We're getting closer to the heart of what makes quantum mechanics so fascinating.
We are, and it's those unanswered questions that keep us going.
Speaking of pushing the boundaries, we talked about the risks of quantum computers for cryptography. But what about the potential benefits? Could quantum technologies actually improve cybersecurity?
Definitely. One exciting area is quantum key distribution, which uses quantum mechanics to create unhackable communication channels.
So even though quantum computers pose a threat, quantum mechanics itself could be the solution for secure communications.
Exactly. It's a perfect example of how the same technology can be both disruptive and beneficial.
We need to be aware of both sides and guide the development in a responsible way.
And that brings us back to the need for open discussions and ethical considerations.
As we unlock these powerful technologies, we need to make sure they're used for good.
We have to make sure they don't create new problems or make existing inequalities worse.
That's a big responsibility.
The quantum revolution offers amazing opportunities and huge challenges. We need to be thoughtful and make sure everyone benefits while minimizing the risks.
I think we've covered a lot of ground in this part of our quantum deep dive.
We've explored the potential of quantum technologies to revolutionize industries and change our world.
And we've talked about the ethical considerations and the need for responsible development.
So be sure to join us for the last part of this deep dive.
We'll wrap up our exploration of the quantum world and discuss the philosophical implications of this amazing field of science. And we're back for the final leg of our quantum journey.
It's been a wild ride exploring the quantum realm.
I feel like we've only just begun to grasp the vastness of it all.
That's what's so amazing about quantum mechanics. There's always more to discover.
It really makes you realize how much we don't know about the universe.
And how much more there is to learn.
That sense of wonder is what drives scientific discovery,
pushing us to keep exploring those quantum mysteries.
Speaking of mysteries, what are some of the big quantum puzzles that still keep you up at night?
Well, one that I find particularly fascinating is the nature of consciousness.
And how it relates to the quantum world.
Exactly. Some physicists think consciousness might play a role in quantum measurement.
Like it helps collapse the wave function and force those multiple states into a single outcome.
It's a pretty radical idea.
I've heard about that. It's definitely a controversial topic.
There's no scientific consensus on it. But it's a question that really makes you think about the nature of reality.
It goes beyond just physics. It touches on philosophy and our understanding of existence itself.
And that's what I love about it. Quantum mechanics challenges us to think bigger and question everything.
So as we wrap up our celebration of 100 years of quantum mechanics, where do you see the field going in the next century?
I think we're on the cusp of a new era of quantum technology, with breakthroughs in computing, sensing, and communication.
We've talked about personalized medicine, ultra-secure communication, and designing materials with incredible properties. What else gets you excited?
I'm really interested in quantum metrology.
What's that?
Imagine sensors that can detect tiny changes in gravity, magnetic fields, or even time itself.
So that could help us with things like navigation, studying the Earth, and even understanding the universe better.
Exactly. And I think quantum mechanics will continue to reshape how we see the universe and our place in it.
It's a journey that's sure to be full of surprises.
And mind-blowing discoveries.
To everyone listening, I encourage you to embrace your inner quantum explorer.
Don't be afraid to ask questions. Dig into the mysteries and let yourself be amazed by the universe.
The quantum revolution is just getting started.
And we all have a part to play in it.
Well, I think that's a fantastic way to end our deep dive into the quantum realm.
It's been a pleasure exploring this incredible field with you.
And we hope you've learned something new and exciting about quantum mechanics.
Thanks for joining us on this adventure. Until next time, keep exploring and keep those quantum questions coming.
And remember, the universe is far stranger and more wonderful than we can imagine.